Hello everyone, today we'll be discussing the unsaturated hydrocarbons, that is alkenes. Now what are alkenes? Alkenes are the unsaturated hydrocarbons containing at least one carbon-to-carbon double bond, that is carbon-to-carbon double bond where the carbon atom is sp2 hybridized. Now alkenes are also known as olefins and have the general formula for alkenes is CnH2n, where N will start from 2. Now let's check out how alkenes are prepared. The first method is from preparation method of alkenes. The first method from alkyl halides. Now the method of preparation from alkyl halides or alkyl halides is also known as dehydrohalogenation or beta elimination reaction. Now in this reaction, the alkyl halides on heating, let's take an example here. Alkyl halides, H here, Cl, this is ethyl chloride. Ethyl chloride on heating with alcoholic potassium hydroxide, which is dissolved in alcohol, it eliminates one molecule of halogen and it leads to the elimination of one molecule of halogen to form alkenes. Therefore, our alkenes is formed here with the elimination of one molecule of halogen acid. Now halogen acid, there is removal of this HCl halogen as hydrochloric acid, therefore there is elimination of halogen acid. Therefore this is the preparation method of alkenes from alkyl halides. This is also known as dehydrohalogenation reaction because there is removal of both the halogen as well as the hydrogen in the form of halogen acid. Also, it is an example of beta elimination reaction because the hydrogen is eliminated from the beta carbon atom. That is, this hydrogen was eliminated from the beta carbon atom. Now, what is the beta carbon atom means? There are two carbon atoms here. Since the halogen is attached to this carbon atom, this will be our alpha carbon and this will be our beta carbon. Therefore, there was elimination of the hydrogen from the beta carbon. Therefore, this is also known as beta elimination reaction. Now, let's check out more examples of this from this type of preparation. CH3, CH, CH2, H and I. Now this is our 2-iodopropane. 3 carbon atoms, therefore these are iodine in the presence of alcoholic potassium hydroxide. When we heat it, there is removal of this halogen acid. Therefore we will be getting here CH3, CH double bond, CH2 because the bond goes here, and we will be getting here H. This is our 1 propene molecule. Therefore, in this way, alkenes are prepared from alkyl halides. Now, one important thing to be kept in mind is that now let's do another set of example. That is, here there is a condition for this step. For this example, CH2, here is our H, makes it methyl, CH, CH3. Let's take here H and then Br. Now this is our 1, 2. The halogen should get the lowest number, so 1, 2, 3, and 4. 2 bromo 4 carbon atoms, therefore there are 2 bromobutane. Now what is the product of 2 bromobutane? Now the product here is there will be removal of halogen HBr. Now it can be removed in the first. This can either be removed or this can either be removed. Therefore, let's check out the first one, that is if this is removed. Now if this is removed, this goes and this goes here, therefore it will be CH3 CH double bond CH and then CH3. Now this will be our 1, 2, 3 and 4. There are 2 butane molecule. Now if we consider the removal of HBr from the first carbon atom, then we will be getting here CH2. This will go here, therefore CH2 double bond CH CH2 and then CH3 there. This will, since this is carbon number, it will be 1 butene. Now there is a condition for this type of example reactions for the preparation of alkenes from alkyl halides. Here Satev's rule is followed here, that is the major product will be the one containing more alpha hydrogen atoms. Now this is the common functional group. Now alpha hydrogen after a double bonded carbon atom, and the next carbon atom after the double bonded carbon atom will be our alpha. Therefore we have here 3 alpha hydrogen, which makes it we have here 6 alpha hydrogens in this case. Now this is the case here, only 2 alpha hydrogens are present here. Therefore the major product, according to Satev's rule, the major product would be the one having more alpha hydrogen atoms. Therefore this is our major product. Therefore when 2 bromobutane reacts with alcoholic potassium hydroxide, the product form will be 2 butene and not 1 butene. This will be our major product according to Satev's rule. Now let's check our second preparation method of alkenes, that is from vicinal dihalides. Now what are vicinal dihalides? Dihalides means 2 halogen atoms will be attached here. Vicinal dihalides, now that means the halogen atoms are vicinal, means the halogen atoms are bonded to different carbon atoms. Therefore now from vicinal dihalides in which the 2 halogen atoms are attached to 2 different or adjacent carbon atoms, they are known as vicinal dihalides. Now vicinal dihalides, when they are treated with zinc metal in alcohol, it loses a molecule of ZnX2. Therefore zinc metal in alcohol, on heating we will be getting our alkene here, the removal of ZnX2 molecule to form an alkene also. This reaction is known as dehalogenation reaction because there is removal of both the halogen atoms. Therefore this is also known as dehalogenation reaction. Now check out an example here. CH CH2 Cl Cl. Now this is 1, 2, 3. 1, 2 dichloro, 3 carbon atoms, therefore it will be propane. 1, 2 dichloropropane. When it reacts with zinc dust in alcohol on heating, we will be getting here both the halogen atoms will be removed. Therefore this go here and this H3C CH double bond and CH2 plus ZnCl2. Therefore our product here will be propene molecule. Now if we take a cyclo compound, this is our 1, 2 di 1, 2, 3, 4, 5 and 6 carbon atoms. 1, 2 di bromocyclohexane. This is our 1, 2 dichlorocyclohexane. Zinc in alcohol, on heating we will be getting, there will be removal of this, therefore we will be getting a double bond here with the removal of Z and B here. Therefore, this is the preparation of alkenes from vicinal dihalides, where vicinal dihalides are the halides where the two halogen atoms are bonded to the carbon atoms adjacent to each other. Now in the next video, I'll be discussing the remaining two preparation methods of alkenes.